What's the chance that y is 0, 1, or 2? Sorry? 1, yeah? Those are the only possibilities for y. Okay. What's the chance that x is 0? Toss a coin 3 times. 50% chance it's a fair coin. Tosses are independent. 50% chance that it lands heads the first time. 50% chance it lands heads the second time. 50% chance it lands heads the third time. In order for x to be 0, it has to land tails all 3 times. Okay? So the tosses are independent. So the chance it lands tails the first time and the second time and the third time is the chance it lands tails the first time times the chance it lands tails the second time times the chance it lands tails the third time. That's the independence in action. Right? So we have a half times a half times a half. It's an eighth. Good? So the chance that x equals 0 is an eighth. I'm not sure how to do this clearly. I guess I'll put the probabilities here. So the chance of that is an eighth. And what's the chance that y is 0, 1, or 2? We just said it's 1. So the chance that x is 0 and y is 0, 1, or 2, because x and y are independent, I can just multiply. That's an eighth times 1, and the whole contribution of this is an eighth. What's the chance that x is 1? So this is a probability, this is a probability, this is a value. Okay, how can x be 1? I need to get 1 head and 2 tails. Yes? That 1 head could be on the first toss, or the second toss, or the third toss. That's a partition, right? Because if it's on exactly the first toss, it wasn't on the second toss. If it's on the second toss, it wasn't on the third toss, et cetera. Okay. So what's the chance that I get a head on the first toss and then 2 tails? That's an eighth, right? A half times a half times a half. What's the chance that I get tails on the first toss, heads on the second, tails on the third? Half times a half times a half is an eighth. What's the chance I get 2 tails and then a head? Half times a half times a half is an eighth. Yes? There's 3 disjoint ways that I could get 1 head and 2 tails. Each of them has probability an eighth. So the chance that I get exactly 1 head in those 3 tosses is 3/8. Yes? What's the chance that I get 1 or 2 heads in the last 2 tosses? Well, it's the chance of anything minus the chance that I don't get any heads at all. Right? You can find probably the complement is easier in this case. The complement of the event that I get 1 or 2 heads is the event that I get no heads at all. Yes? Because those are the only possibilities here. What's the chance I get no heads at all in the last 2 tosses? Quarter, right? Tails, tails, a half, a quarter. So the chance that I get either 1 or 2 heads is 3/4. Yep, 1 minus a quarter, so this is 3/4. And the overall chance that this row happens, that x is equal to 1 and y is equal to 1 or 2, is 3/8 times 3/4 because x and y are independent. So 9/32. What about here? What's the chance that x is equal to 2? You need to get 2 heads and 1 tail in the first 3 tosses. Those could be heads, heads, tails, heads, tails, heads, tails, heads, heads. Right? I have 3 choices for which one gets tails. Just like here I had 3 choices for which one gets heads. Same probability, 3/8. What's the chance y is equal to 2? Quarter. Okay, so this is 3/8 times a quarter by independence, which is 3/32. Okay, 1/8 is 4/32. So I've got 4 plus 9 is 13, plus 3 is 16 over 32 is a half. Okay, so overall, this whole probability is a half. Everybody follow all the moves? We used independence a lot. Used independence of all the tosses. We used the complement rule to find the chance of getting either 1 or 2 heads by subtracting the chance of getting no heads from the chance of getting 0, 1, or 2.